Bismillahirrahmanirrahim. In today's class, we will be discussing the sorting algorithms. One of the two most well-known sorting algorithms are bubble sort and quick sort. In today's class, our focus will be on the bubble sort algorithm. So, uh, in every data structure, uh, one of the very common problem is to sort all the data in some specific order. So if you want to sort the data, existing data in some specific order, then you need sorting algorithm, and bubble sort is one of the very well-known algorithm for doing their job. So as you can see from its name is bubble sort, which means it's the strategy of this algorithm is focusing on bubbling up the smaller elements to the top. So smaller, or it can be a larger element. So if your strategy is to bubble up small elements, then the data will be sorted in ascending order. If your strategy is to bubble up larger element, then the data will be sorted in descending order. So while explaining this bubble sort algorithm, you keep in mind that the data is in a random order. For example, you may suppose that you have a data of, for example, 10 integers. They are in random order, for example 5, 8, 9, 3, 2 something. So their data is in random form and they are not sorted. Then we will apply the bubble sort algorithm. The pseudocode for bubble sort algorithm is mentioned over here. Keeping in view their data arranged in non-sorted form, random form, you start from the start of the list of the data, and you keep on performing some specific operation till it ends. So what is that that specific operation? That you compare existing element with the previous element, and if the existing element is greater than previous element, then you swap it, you bubble it up, you swap it, and you keep on performing this operation till all the data is arranged in a sorted form. So what does it mean? In order to clarify this definition of this pseudocode of the bubble sort, we will consider a graphical example. In this example, consider this 5 elements integers data. You can consider it in the form of a list. The list has first element is 10, the second is 9, then 8, 11, and 4. You can see that the data is not in a sorted form. So we will apply bubble sort algorithm as per definition which I explained in the previous slide, and we will see how it will become a sorted data. So in order to explain this bubble sort algorithm, this is the same data. The first element is at the top and the last element is at the bottom. As a first step, you will consider its first element is the element for which you will make a decision. The first element is 10. 10 will be compared with the next element, that is 9, and the condition is that if the current element is greater than the next element, then we have to swap it. So here the condition is true, so we will swap it. So 9 and 10 are swapped. Now our focus will turn on to the second element. The second element is 10. Now the same step that we performed in the previous case will be again applied here in this case, where we have the current element as 10 and the next element is 8. So 10 will be compared with 8, and as 10 is greater than 8, they will be swapped. Now we have to take this process to the end. What does it mean? We have to move to this process is not yet completed, because we have still the 8 and 9 elements remaining to be swapped. So we have to bubble up the smallest element among 10 and 8. Here now we will move up, we will compare 9 and 8, and as 9 is greater than 8, we have to bubble up the 8 element, means we have to swap 9 and 8. So that's done. So as 2 steps are now completed, in the third step our focus will be on the third element. The third element is 10. So 10 will be compared with 11, as 10 is not greater than 11, and we know that the element above the 10 is already in their appropriate location, mean in sorted form, then it's not possible even to consider the upper elements for further swap operation. So the third step is quickly completing after this condition becomes false. Now we will move on to the fourth step. In the fourth step, our focus will be on the fourth element, that is 11. So 11 will be compared with the next element, that is 4. And as we can see, 11 is greater than 4. We have to swap it, and then we need to keep on continue. We will continue on with the swapping operation till we reach to the top. So after performing the swap operation, 11 and 4 will be swapped. Now our focus will be on the upper element, that is 10 and 4. We have to swap him. Now our focus will be 9 and 4. As 9 is greater than 4, we have to swap them. And now your focus will be on 8 and 4. As 8 is greater than 4, we have to swap them. So after this date is the last operation. After performing this last operation, we can see now that the data is already in the sorted form. Now if we look at its code, if you want to implement its code, it will be something like this. This is a C code. We have developed a function which is performing this bubble sort algorithm. Name of the algorithm, the name of the function is bubble sort. To this we will pass an array of integer elements, and we will also provide an argument named size, which will represent the size of the array. Because we have passed this array as a pointer, and the pointer do not have additional information about the size of the memory containing elements that is pointed to by this pointer. Therefore we need an additional information, that is an integer size, to represent the total block size that is pointed to by this pointer a. So we have defined two variables in ij and temp. There are two nested loops. The first loop is from start till size -1, so the second last element, and the second loop will start from j is equal to I till j is greater than or equal to j minus minus, and it is exactly the same operation that I graphically represented in the previous slide. The current element is compared with the next element, and if this condition, if the current element is greater than the next element, then we will perform the swap operation, and if this condition is false, we do nothing and we move on to the next step. So this is an attractive algorithm implemented using two nested loops. This will perform exactly the same process that I explained you graphically. So that is all about the bubble sort. There are a few observations that in real world scenario, generally we do not usually sort numbers, but if you have a database of students, and for example if you have real-time database, which for example there will be a database of students, and if you want to sort those students on the basis of their CGPA, then you have to sort not only their CGPAs, but you need to sort actually this complete student's record using the key that is CGPA. So we do not usually sort numbers, we usually sort records with reference to some specific key. The decision making is with reference to the key, and after sorting those records, all the data will be sorted in terms of the key. So generally for if you have a data record in the database, for example student, there will be multiple entries related to each student. For example, the student's name, CNIC, date of birth, CGPA, current year in which he is enrolled. So all this data will be related to a student. If you want to swap the complete data about the students, it's a better practice to write a function to perform those swapping operation. So after bubble sort, another similar type of sorting algorithm is selection sort algorithm. In the selection sort algorithm, uh, as we discussed, just like in the bubble sort, we represent the data in the form of a list, random containing random entries. And the idea of the selection sort is that you go through all the elements, you identify the largest element with the existing list, and then swap it with the last element. After every operation, the pointer to the last is decremented by 1. So initially last is pointing to 13. In the next step, the last will be pointing to the so in the first step it's pointing to the fifth element. In the next step it will be pointing, the last will be pointing to the fourth element in the next step, and after that it will be pointing to the third element, and so on and so forth. So let's try this example. So in the first step, if you go through all the elements, the largest element is 37 and last will be pointing to 13, so it will be swapped. Now in the next step, last will be pointing to 13, and if you search from the first to the last element, the largest element is 29, so 29 will be swapped with the 13. Now in the third step, last will be pointing to the 14, and if you search from start till 14, you will find that the largest element is 14 and last is also already pointing to 14. Then in this case you do not need to swap anything. In the second last step, last will be pointing to 10, and from 13 to 10 the largest is 13. 13 will be swapped with the last element, that is 10. And at the end of this process, you will see that in the fourth in the last step, you can see that all data is already in the sorted form. So if you want to consider a pseudocode of consider the pseudocode of this selection sort algorithm, we have total n minus 1 element. In in the first step, you select the largest element, swap it with the last element, you decrement the last element, and you keep on doing this till last is equal to or less than 1. This is the actual code of the selection sort algorithm. The function we have written has a name selection sort. To this we will pass an array containing data, and int n will be representing the total number of elements in that array. So we define an integer variable index of largest, index, and last. In this we executed a loop starting from the last element till last is greater than or equal to 1, last minus minus. So first we make index of largest equal to 0, and again in the nested loop we will start from 1 till the last. Last is actually an index in the upper loop, and from start till that last element we will check we will identify the largest element. At the end of this loop, index underscore of underscore largest will be containing the index of the largest element, and that indexed element will be swapped with the that index element will be swapped with the element contained at the last location. So the algorithm is exactly representing. This algorithm is exactly a representation of what we have done in the previous slide. That is this graphical representation. So again, In order to explain it again, we have a function. To the function we passed an array containing n elements, and then we define two nested loop. The first loop is have an index named last, starting from n minus 1 till first element, and the next loop starting from first till the index of the upper loop, that is last, and at each step it is checking that the current element is greater than the current element is greater than the next element or not. Whenever this condition becomes true, the index will contain the index of the largest element. After end of this loop, index underscore of underscore largest will contain the index of the largest element among the list of element that we have considered, and that indexed element will be swapped with the last element, and we will keep on doing this till the condition last is greater than or equal to 1 becomes false. So when this condition will become false, means that we have performed all the operations on the data required to sort the existing data using selection sort algorithm. Thank you.